Hi everyone, welcome back to Dragonfly Engineering. So this week I'm going to show some updates on the mass production infrastructure equipment for the 250-ton dual shot molding machine, this one you see here. And the first one that I'd like to show is our mold temperature controller, which is this guy. The other will be some of this drying equipment that I finally started to implement or integrate into the machine. So here you can see we've got a dryer unit plus 2 hoppers, and then the hot air distribution system that feeds into our vacuum loaders, which I've shown in a separate episode, but we can look at that again. But first, let's check out the mold temperature controller, mostly because when this dryer turns on, it's a little noisy, even though there's airplanes flying over right now. Yeah, so we need this dedicated temperature controller because in this dual molding machine, we've got effectively 4 blocks of metal or steel that need to be temperature controlled. So there's the A and B side of the first mold, which are these, and then there's the A and B side of the second mold, which are those in the back. So for those who don't know, this is a dual shot machine, so it can over mold or run 2 molds simultaneously with 2 injection units back here, and effectively just a double side platen with 2 ejector systems for 2 molds. Yeah, so because of all this metal mass, we pretty much need to have a dedicated temperature controlling system to both heat and cool the molds, which is this guy. And actually my brother did a lot of work on this. He machined the chassis and the front panel and the back panel on the base, and also a relay array for turning water lines on and off, which is controlled by this unit as well. I'll show you that in a minute here. But first, let's plug this thing in. So this is a 30 amp plug. It's a 3-phase plug, but actually we're only using 2 phases, or 208 volts. So I'm just pulling off 2 of the 3-phase legs of this 3-phase circuit. And let's see if I get this right. There we go. And this is a twist lock, so you twist it and then it locks in place. Okay, so this is a 10 gauge 3 conductor cable going back over to the temperature controller unit. I've got some video of this system being built, both machined and wired up by my friend Betsy. And I do have one light and one stuck switch that I need to fix, but we can look at that later. So yeah, we'll flip on all of the temperature controllers. These are auxiliary, which aren't really hooked up to anything right now, so we won't worry about that. And then we can flip on the heaters, and you'll see that these temperature controllers are basically powering up, and we've got amp meters down here, which basically show the actual amperage, the AC amperage that's going through the heaters. So this guy here, oh, actually I've got a disconnected sensor. That's what the U's mean. So that one's not turned on. And this heater is disconnected as well because I was reconfiguring things. So anyway, I can see what's happening. So for instance, I know that I turned this heater off in the mold. Let's go over and check. So you can see right there that I've disconnected that heater temporarily. I actually moved it to the other side, but it doesn't matter. So yeah, and then over here you can, so this guy is telling me, yep, there's no current going. I do have voltage going to that heater, but there's just no current flow. This heater is working, and this heater is working, and this one is not because a temperature sensor is disconnected. Let's see if I can look back here. And back here you can see some of the hookups. So this wire has a sensor that's disconnected somewhere. And I'll have to track that. Oh yeah, you can see right here. So this temperature sensor is also disconnected. And so it's nice to have all this information. My previous temperature controller would just show that it's putting voltage out, but it wouldn't necessarily tell you if you're actually transmitting power to the heaters themselves. If I flip this heater off, then you can see how the amperage goes to 0. So it tells me a lot more information, and I probably should have prepared a little better before this this video. We can also turn on cooling circuits. That's what the C is over here. And there I've turned one on, and you can hear the hum of a relay in the back. And this one turned on because there's no temperature sensor, so it knows that, well, I should turn on the cooling system. It's kind of a safety factor. If you lose a temperature sensor, it'll automatically turn on the cooling water for your mold to cool it off because you're in like a fault state. You can turn that off. And then this one turned on as well. This one turned on because I set the cooling temperature very low when we were testing this. And yeah, I've got some more footage of that as well to show. So let's take the cover off and we'll see what we got inside. A quick view inside. So down beneath this weave of wire, you can see how we've got DC to AC relays, which are switching the heaters on and off. And the front here are the MyPen temperature controllers. This is what it looks like in the front. I get these on Amazon. They're not sponsored or anything, but they work really good. They're easy to use. And yeah, we've got all sorts of switches to turn on the units or turn on and off output power to the chiller circuits or the solenoids that turn on water to the molds themselves to cool them off. And we also have a switch that actuates or can break the circuit that goes to the relay. You know, you can't really power the heaters directly from these little tiny switches because these aren't really rated for much current at all. But what it's doing is it's switching the solid state relay DC signal that would activate the high current relay switcher, which switches the AC power on and off, which is behind all those wires. And you can see that red light is on. That means that relay is active. And fuse, got another fuse array. I highly recommend having, what I use is these automotive fuses to fuse each individual heater circuit. If you don't have a protected circuit and one of these relays blows, then it turns into quite the smoke and electric show. And a lot of times they'll go down the line. You know, one will blow and then the next one blows. Pretty soon your entire guts are blown out on this thing. I do have a schematic which I can show, which I basically hand drew for my friend Betsy, who wired all this up. There's no guarantee that the schematic is correct, but I'll put a screen capture here so you can at least see the psycho ramblings of an engineer who designed this monstrosity. Again, no guarantee of completeness or accuracy, so use at your own risk if you can decipher it at all. Anyway, so that is the temperature controller. We can go around to the other side of the molding machine where I've got the output of the cooling system, which is this cable, which will go and activate individual water circuits on the backside. So let's go over there and check it out. The shop is still generally a mess. So this is the relay system. So we've got 4 water relays that will turn on and off from a signal from that temperature controller. If we get a over temperature, which you can set on those little MyPen controllers, one of these relays will turn on and off. So the first relay, which we left on, is the A side 1, or the front side of the first mold. If I had this actually completely hooked up, then we'd be running water through that mold, cooling it off. But we're just starting up, so I'm just kind of demonstrating. I'll just shut these relays off. In fact, I need to finish hooking up all of the hose from the water system water manifold through into our 4 relay circuits and then up into the molds themselves. So yeah, that's where we're at with temperature control, and this is definitely going to help because I'm going to be running this molding machine all day today. So I've got a 16-hour run ahead of us. So this is definitely going to be cooling things off in a few hours. All right, well, we're about at the end of the day, and the temperature controller's been running great, as well as the new setup for the drying of the plastic and conveying the plastic. and parts are ejecting automatically, so that's always nice. So I'm going to show you some footage of how we made this temperature controller. It was not a refined engineering process. It was pretty much just making it as quickly as we can to get it in operation here. So I got this panel that my brother made back in on the East Coast approximately a year ago, and I may still have some footage of him making this panel, but this is a front panel for a temperature controller, and it's aluminum that he machined, and then I just recently had it black anodized, and it houses a whole bunch of these amp meters. Come in with our drill. There's a couple of LED holes at the top that I'm gonna, actually I need to update the zero position. I found the zero in the center of the hole, but the program zero is here. So this is why you want to reduce your rapids when you start a program so you don't drill into your vise, like I did there at one point. All right, let me reset the zero. All right, so we'll move to the new zero location. Now we can run. That looks right. Once we know we're good in our cut, then I'll increase the rapid and give it a little coolant. So here I'm drilling the plunge hole for the 1/8 end mill to cut out that square pocket. It's better to drill your plunge holes for end mills wherever you can, as opposed to just plowing it through, because end mills don't do so good at cutting out the center part.
into the switch.
Yeah, would be the black wire going into the switch.
Right, and then so then I was like, okay, what do I do with these two black wires? Because one of them,
Oh, you know what? That switch may actually turn off the neutral as well.
Does this look right? This is going.
Well, if it ohms out, if there's a short between the two whites, then it's okay. Oh, there's no fuses yet? Oh, yeah, we'll need those. They should be next. If they're not over here, then they're next door. Well, these banana plugs are not very robust.
And now.
Fuse is good. All the front modules were just off.
I did that before you plugged it in because I wanted to make sure that nothing exploded.
Oh, thank you.
So I was like, we'll start with everything turned off. Another.
All right, that's plugged in. And then the center switch. Ooh, there's light. That's good. So it's set to 100 degrees. So if we flip on the hot switch, oh yeah, the amp meter's not showing much. And that light will turn on. It is reading the temperature though. 19 degrees C. Let's read our temperature. LEDs. Yeah, these LEDs pick up stray voltage. That one's on a little bit. And when I was testing with the resistor, I could see a faint color as the voltmeter probe approached the wire. It's like they're very sensitive. All right, let's see what's going on.
Just like us. Don't want to miss any
Well,
dialogue.
it's so close, and it already started doing its fuzzy logic, I think is what they call it, where it's controlling the temperature better now that it went through one overshoot and it figured out what to do. So
the blinking H.
Yeah.
Hot. Does it stop blinking when it's reached its temperature, or is it just always blinking for?
It will. It'll stop blinking when it hits the temperature,
Okay.
and it's just bursting energy out and trying to figure out how the mass will respond to that energy, and then eventually it'll just be a constant little burst, and it's putting energy into the block as the block is emanating or convecting heat energy away. So it already learned a lot from the first time we ran it, so that's why it's not going up to 80 right now. So for us to test the cooling circuit, we can turn it on, but the alarm is what actually tells the thing to start cooling. So we're gonna have to trick it by going into setup mode and then telling it that it needs to respond or react, oops, if the temperature is greater than the current one, which is like 40 degrees. So we'll set this to 30 degrees. And we heard the relay turn on.
Yeah.
And the blue light's on, which is good. That means it's cooling.
Yeah.
And it stopped heating because the controller's like, well, we're too hot now.
What's going
So when
on
I
here?
flip,
Are there any lights on?
oh yeah, that's energized too. I see.
Yeah, the lights are on. 2 lights.
Oh, 2?
Yeah.
No, there should just be 1.
Well, there's 2 lights on, 2 green
That
lights.
one on next. So if I flip off the output to the cooling output, we should hear the relay click off. So let's do that. And it turned off. Nice. So basically the alarm means turn on the water to cool off the block until we get below the set point temperature, which I think we set at 35 or 30. But, and the heater is still, actually it just burst a little bit. So you just see just the beginnings of a pulse of power going into the heater block. Because it's only 2 degrees away. What's up, Sierra? You fussy, Sierra? Huh? You want to go for a walk? All right, we'll go for a walk in a second. Let's finish up with this. Make sure it won't blow up on us. So yeah, right now we're heating and cooling because I set the alarm temperature below the heating temperature, which would not be a normal operation. I haven't set the heat for the rest of them yet, but we can. And there's no connection to a heater load, but we can flip on. Oh, actually, it's saying there's no temperature sensor attached. That's what the U's mean. So it's not going to do anything. Oh. Oh, okay. Well, I guess these default in alarm state when the temperature sensor is not attached. That's kind of cool. So if we lose the temperature sensor and the heaters start to run away, get super hot, then this thing says there's an alarm because you've got a fault in your sensor, so turn on the cooling system, which is neat. Okay. Nice. And they all seem to be working. Got to figure out that LED though.
Ooh, that one.
That's the one that's probably not.
Oh, yeah.
It's got some issue. Okay, so welcome back. So I think this will be a wrap for this week. I've been super busy and actually making 3 new molds, which we're going to show in future episodes, and they're pretty cool ABS white parts. And yeah, so I've been busy making those the last few weeks, so sorry about this. Yeah, so sorry about the lack of videos, but it's been kind of a major crunch of work. Anyway, so I'm past it now, so I'm going to be releasing a lot of videos of making the molds that are running now, plus the follow-up of the other mold, the 4 black shrouds that I started a video on. And then a bunch of other things, kind of shop infrastructure deals. All right, well, thank you for watching, and I'll see you guys next week. Goodbye. Don't do this at home.
Yeah, I was gonna say don't put this in a video. This is
Instructional video.